Let us look at the third problem. The third problem is an experiment involves rolling a pair of dice and recording the numbers that come up. Describe the following events. A. The sum is greater than 8. B. 2 occurs on either die. C. The sum is at least 7 and a multiple of 3. Which pairs of these events are mutually exclusive? So the experiment of rolling a pair of dice is given to us. Then the events we have to find out are A, B, C, and then we have to tell which pair of these events are mutually exclusive. So let us start solving the problem. Solution. So let us write first the random experiment here. So random experiment is rolling a pair of dice. Rolling a pair of dice. Okay. So 2 dice are rolled. That means sample space will be. So you can get 1 on the first dice, 1 on the second dice, right? 1 on the first dice, 2 on the second dice, like that. 1 on the first dice, 3 on the second dice, 1 on the first dice, 4 on the second dice, then 1 on the first dice, 5 on the second dice, like this. 1 on the first dice, 6 on the second dice, or 2 on the first dice, 1 on the second dice, right? Then 2 we will get here, 2 3, like this you have to write. 2 4, okay, 2 5, then 2 6, right? Then 3 comma 1, 3 comma 2, then 3 comma 3, then 3 comma 4, right? 3 comma 5, 3 comma 6, okay, 4 comma 1, 4 comma 2, 4 comma 3, right? 4 comma 4, 4 comma 5, 4 comma 6, okay. Then we can get 5 on the first dice, 1 on the second dice, 5 on the first dice, 2 on the second dice, 5 on the first dice, 3 on the second dice, 5 on the first dice, 4 on the second dice, right? Then 5 comma 5, then 5 comma 6, then 6 comma 1, 6 comma 2, right? 6 comma 3, 6 comma 4, okay, 6 comma 5, and 6 comma 6, right? So this is what we will get as the sample space. Now let us write the event A. So event A is getting the sum greater than 8, the sum greater than 8, right? So let us write the event A. A will be equal to, since sum is greater than 8, so we have to look at this sample point, 3 comma 6, right? This is 3 comma 5, so 3 plus 5 is 8. All these numbers here will give sum less than 8, so we have to take the sample point is 3 comma 6, because the sum is 9, right? So 3 comma 6, then what we will get is 4 comma 5, right? 4 comma 6, 4 comma 5 is 9, so greater than 8. Then 5 comma 4 comma 6 is also greater than 9, which is 10, right? Then this 5 comma 4, right? 5 comma 4, then 5 comma 5, then 5 comma 6, okay, this we got. Then we will get 6 comma 3, 6 comma 3, 6 comma 4, 6 comma 5, right? 6 comma 3, 6 comma 4, 6 comma 5, and 6 comma 6 also will be there, right? So this is event A. Now let us look at event B. Event B is 2 occurs on either die. So 2 occurs on either die, right? So that means B will be equal to what? So 2 occurs on either die. So if you look at the sample points here in the sample space, so this will be there 1 comma 2, right? We got 2 occur on the second dice. So the 2 should occur on either the first dice or the second dice or the both dice, right? So 1 comma 2 will be there, 2 comma 1 will be there, 2 comma 2, 2 comma 3, all this will be there. So 1 comma 2, 2 comma 1, 2 comma 2, 2 comma 3, right, 2 comma 4, 2 comma 5, okay, 2 comma 6, okay. Then what you will get next? So 3 comma 2, 4 comma 2, 5 comma 2, 6 comma 2, okay. So have you understood? 3 comma 2, 4 comma 2, 5 comma 2, 6 comma 2, right. Now we will look at the event C. So event C is the sum is at least 7 and a multiple of 3. The sum is at least 7. The sum is at least 7 and multiple of 3, right. So C will be what? Sum is at least 7. So it should be, the sum should be at least 7 means sum should be either equal to 7 or greater than 7, right. So this will be there, 2 comma 5, also 1 comma 6, right. 1 comma 6 will be there because 1 plus 6 is 7, 2 comma 5, and it should be a multiple of 3. So this will not be there, right. The sum is equal to 7, but it is not a multiple of 3, okay. This also will not be there, right, because 7 is not a multiple of 3. 2 plus 5 is 7. 7 is not a multiple of 3, okay. So let us look at this, 2 comma 6, it is 8. It is greater than 7 but not multiple of 3. Then if we look at 3 comma 6, right. So 3 comma 6 means 3 plus 6 is 9, which is a multiple of 3. So 3 comma 6 will be there, right, and therefore 6 comma 3 also will be there because the sum is 9 and it is a multiple of 3. Then if we look at this 4 comma 5, so 4 comma 5 will be there, right. So 5 comma 4 will be there, okay. Have you understood? Then 6 comma 3 we have already written. 6 comma 6 is there, right, because 6 plus 6 is 12 and 12 is multiple of 3. So this is the set C. Now let us tell whether which pairs are mutually exclusive or not. So mutually exclusive means the intersection of both the sets should be non-empty, right, should be empty, sorry. So if you take two sets A and B, if the intersection is empty, then they are mutually exclusive. So let us find out A intersection B first. So A intersection B will be what? Let us look at the common points. 3 comma 6 is not there in B, 4 comma 5 is not there in B, 4 comma 6 is not there in B, 5 comma 4 is not there in B, 5 comma 5 is not there in B, right. 5 comma 6 is not there in B, 6 comma 3 is not there, 6 comma 4 is not there, 6 comma 5 is not there, 6 comma 6 is not there. So this A intersection B is empty set. So A and B are mutually exclusive, that we will write it afterwards. So now let us look at B intersection C, right. So B intersection C, if you look at 1 comma 2 is not there, 2 comma 1 is not there, 2 comma 2 is not there, 2 comma 3 is not there, 2 comma 4 is not there. Have you understood? 2 comma 5 is not there in C. The common points we have to look at. 2 comma 6 is not there in C, 3 comma 2 is not there, 4 comma 2 is not there, 5 comma 2 is also not there, 6 comma 2 is also not there. So again this intersection is empty set, right. Now let us look at A intersection C. So now we have to look at the common points between A and C. So you see that 3 comma 6 is there in both the sets, right. So it will be in the intersection. Then if you look at 4 comma 5, it is also there in both the sets. 4 comma 6 is not there, right. Then 5 comma 4 is there in the both the sets. 5 comma 5 is not there, 5 comma 6 is not there, 6 comma 3 is there here, right. And if you look at the last element here, 6 comma 6 is in the both the sets. So A intersection C is simply the set C here. So let us write down, right, because you can see all the elements of C are there in A. So these elements will be there in the intersection of A and C. So what we will get is 3 comma 6, then 6 comma 3, right, then 4 comma 5, then 5 comma 4, okay, and 6 comma 6. So if you look at the sets, A and B are mutually exclusive because the intersection is empty. So therefore A and B, also B and C are mutually exclusive because again the intersection of B and C is empty. So B and C are mutually exclusive, okay. So have you understood this? Like this you have to solve this. So that was the problem 3. Now let us go to the problem 4. So problem 4 says 3 coins are tossed once. Let A denote the event 3 heads show, B denote the event 2 heads and 1 tail show, C denote the event 3 tails show, and D denote the event a head shows on the first coin. Which of the events are mutually exclusive, simple and compound, right? So let us start solving this. Solution, first sub problem, mutually exclusive. So what is given is 3 coins are tossed, right? So let us write the sample space here first. 3 coins are tossed means you can get head on the first toss, head on the second toss, head on the third toss, right? Or you can get head on the first toss, tail on the second toss, head on the third toss, or you can get head on the first toss, head in the second toss, tail in the third toss, okay. Or you can get head in the first toss, tail in the second toss, tail in the third toss. So like this you have to write the sample point. So again we can get tail, 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 head, tail, right? Or tail, tail, head, or tail, head, head. So this many sample points will be there in the sample space, right? Now we can write the events A here. Event A is nothing but 3 heads show. So 3 heads show. So A will be equal to what? There is only one sample point wherein that is head in all the 3 tosses, that is this event. This is a sample point H, 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 right? So A is a singleton set H, H, H. Then B, let us look at B is 2 heads and 1 tail show, 2 heads and 1 tail show, okay. So B will be equal to what? 2 heads we have to take and 1 tail. So this sample point will be there, right? Head, tail, head, then this head, head, tail, okay. Then this tail, head, head, right? This is the set B. Now let us look at the set C, that is 3 tails show, 3 tails show, 3 tails show, okay. So C will be what? Only singleton set, that is tail, tail, tail. Now let us look at the event D here. D is what? A head shows on the first coin, head shows on the first coin, okay. So the event D will be what? Head show in the first toss. So this H, H, H is there, right? Then H, T, H, then H, H, T, right? And then H, T, T. These are the sample points. Now let us look at the first sub problem, mutually exclusive we have to tell, right? So let us look at the intersection here of the pairs of sets. So A intersection B, let us see. If you look at A intersection B, then there is no common point in A and B. So A intersection B will be empty set, right? Then if we look at B intersection C, then you can see that again there is no sample point common between B and C. So it is empty set here, right? Then if you look at A intersection C, so A intersection C, there is no common point, so it is empty set. A intersection D, if you look at, then there is one common point, it is H, 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 right? So this will be non-empty set, or we can write the set, it is H H H, right? So which is not equal to empty set. Now let us look at B intersection D. So B intersection D, if we look at here, so B, that is this, and D. So what are the common points? HTH is there in B and D, right? Then HHT is there, okay, and that much only is there, okay. So B intersection D is HTH, HHT, right? So which is again not equal to empty set. Now let us look at C intersection D. This is the last pair we have to look at. So C intersection D is what? So C intersection D. So there is no common point, right? So what you can say is, from here A intersection B is empty set. A and B are mutually exclusive. Then B and C are mutually exclusive. C and A are mutually exclusive, and C and D are mutually exclusive, okay, are mutually exclusive. Right, now let us look at the second point, a second question. Simple. So we have to tell which events are simple here. Simple means events which contains only one sample point, or event which contains only one this element, okay. So which set it is, not this. We have to look at the events. This contains only one element, and the set C also contains one element. So only A and C are simple events. So A and C are simple events, right? Now let us go to the third, that is we have to tell which events are compound events. So compound events means the events which contains more than one elements, okay. So you can see that B contains more than one elements. There are 3 elements. D also contains more than one because it has 4 elements. So B and D are compound events, okay. So this is the answer of the fourth problem. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.